Good afternoon. My name is Angelo Iciello, Executive Vice President and Chief Strategy Officer at the American Institute of Aeronautics and Astronautics. AIAA is pleased today to host this Aerospace Perspectives Series webinar, which is being presented by Lockheed Martin. Today, you will hear about Lockheed Martin's far-reaching vision for the future of space entitled Space 2050. And while the date may seem a ways off, I can promise you it'll be here faster than you think. We would also like to welcome a diverse audience from within the aerospace industry, as well as from other adjacent industries that may play a lucrative role in helping to shape this burgeoning market. Lockheed Martin has assembled an outstanding panel of experts for today's discussion. They'll address a wide range of topics, including the challenges we all must overcome to make this future a reality. If listening to this audacious vision today has piqued your interest, you will definitely want to join AIAA and Lockheed Martin at AIAA's annual Cornerstone Space event called Ascend. Ascend will be held on October 23rd through 25th in Las Vegas. On the agenda, more detailed discussions on the concepts addressed today will be presented, as well as the extrapolation of broader technical and commercial challenges that the community will collectively need to address in both the short and longer terms. Building a commercially viable and sustainable off-world future together will take all of us. On a final note, please note that this webinar is being recorded. Should you miss anything today, or would like to suggest this content to a friend, the recording will be posted to the AIAA website tomorrow. So, thank you for joining us today. And at this point, we'll turn the program over to Nelson Pedrero, Vice President with Lockheed Martin's Advanced Technology Center. Nelson?
Angelo, thank you. Thank you for the kind introduction. And thank you to the entire AIAA team for the opportunity to be here to share our Space 2050 vision for the future with the broader space community. So a couple logistics here. We're going to go through introductions, and following that, I'll give you a broad brush view on the background of Space 2050 and what the big vision entails. And then we're going to hear from our panelists. As Angelo indicated, I'm Nelson Pedrero. I'm the Vice President of the Advanced Technology Center for Lockheed Martin Space. We are the innovation labs for space, and delighted to be here with you today. Let's go to the introduction of our panelists, and we'll start with Aura.
Hi, everyone. My name is Aura Roy, and I'm currently the Deputy PM for MUSE, which stands for Multi-Slit Solar Explorer. I just joined this team about 2 weeks ago, so I'm still learning about it myself, but MUSE is a spacecraft mission designed to study and collect measurements of the sun's eruptions and solar flares at a resolution higher than any other NASA solar mission. And we hope to use these measurements to hopefully predict when these solar eruptions and flares will happen, which is so important as they can adversely affect satellites that are in space, which those satellites affect everything from, help us from everything from agriculture to communications. They affect the people going into space, which more and more people are, and even affect us down here on Earth as it can adversely affect the power grids. And so it's a really exciting mission, and I'm super happy to be on it. And just prior to this role, I was helping to manage a multi-million-dollar portfolio of research and development projects. So that's a little bit about me, and I'm really excited to be here to talk to you all about Space 2050. And now I'll pass it on to Joe to introduce himself. Thanks.
Thanks, Aura. I'm Joe Landon, and I am the CEO of Crescent Space. I'm also very excited to be here today. Crescent is a new commercial company that was formed by Lockheed Martin to provide commercial infrastructure services at the moon and beyond. We're building the Parsec network, which is a constellation of satellites at the moon to provide reliable high-speed communication services and navigation services to missions on and around the moon to fuel that Space 2050 future that we're talking about today.
All right, and good morning or good afternoon, depending on where you are. My name is Kate Watts. I'm our Vice President of Human and Scientific Exploration here at Lockheed Space. And so my team is focused on mission strategy and advanced technology development and planning related to the commercial civil space part of the industry. And so thinking about Space 2050 and trying to envision that future and pull it left as much as possible is what we do every day. So excited for the opportunity to share that and talk with everybody today. Thanks. David?
Thanks, Kate. I'm David Lackner. I'm the Senior Manager for Strategy and Business Development for our Ignite initiative. Ignite is where we develop forward-leaning technologies and look to the future for how we establish all the processes, technologies, innovation, R&D, and developmental efforts to get to 2050. I was also lucky enough when this initiative to chart out Space 2050 and what it meant for us and the broader aerospace industry to lead the team to figure that out. It was a exciting and very tough assignment. And I think what you'll hear today about 2050 will show you where we ended up and how excited we all are for the future. So I'll pass it back to Nelson. Thanks.
Very good. Thank you all. So before I share with you this big vision, another logistics piece, we will have time for Q&A at the end if we manage the dialogue here well. So please enter your questions on the question box, not the comments, because we're going to be monitoring the question bubble here on Zoom, and hopefully we'll be able to answer your questions at the end. So what is Space 2050, right? And why 2050? So Space 2050 is an initiative that we started about 2 years ago at the Advanced Technology Center at Lockheed Martin Space. And it's really not as much as predicting the future as it is to envision the future of space. And the reason we wanted to do that is, even though there's what I like to call large error bars or uncertainties as you try to envision or forecast what's going to happen that far out, when you look at different vignettes and different scenarios for this future of space, we start to see some patterns and some fundamental capabilities and enabling technologies that start to repeat themselves and show themselves as enabling of this future space endeavor in future space scenarios. And that's really what we were positioning ourselves to, is to create a vision for the future that will really position us to make that future happen, and also develop the technology discriminators, and frankly, also to prevent surprises. So that's really what this is all about. Why 2050? Well, we didn't want it to be too far in the future that it became science fiction, but also not too close, right? That it's a program that we are working on today. And 2050, right, 27 years out is long enough that we can truly develop disruptive technologies and disruptive capabilities. So that's a little bit of the background there. In envisioning what the space ecosystem is going to look like in 27 years from now, in 2050, right? I just want to take a moment to talk about what's going to be happening on Earth at that time. That's extremely important, right? On this time frame. And what we expect here is really another quantum leap in terms of integration of design and analysis tools that, combined with advances such as no harness integration, automated prototyping, and manufacturing, will inherently change the balance between recurring and non-recurring costs for the development of space systems. This will enable commoditized, on-demand production of spacecraft that can be tailored to specific needs and can easily incorporate new technology. More importantly, innovation, with this kind of scenario, with this kind of integration, innovation will be limited only by the speed of ideas. Next comes access to space. And on this time frame, I expect the trends that we're seeing now in terms of lower costs for launch will continue, as well as new business models that will in fact allow what I call, quotes, no cost access to space, close quotes, where the business model or the business case closes with revenue from the systems after deployment. This will make access to space accessible and available to a much broader much broader community, if you will. I also expect regular and on-demand access to space. And in this time frame, we should take seriously the potential for alternative technologies to the traditional launch, such as a spin launch, and why not a spin space elevator. So access to space will also expand from LEO, MEO, GEO into Cislunar, and there will also be a political and international expansion, with most countries having a presence or at least a national interest in space. Finally, we get to space, and that's really where we're going to spend most of the dialogue here with our panelists today. And in space, we expect an exponential growth of proliferated, networked, and autonomous systems. This is a trend that has started, and with a number of constellations proposed and some being deployed with thousands of spacecraft. We will also going to see on-orbit assembly, repair, and some level of on-orbit manufacturing. And a very critical element is infrastructure. Think about trusted, reliable, high bandwidth communications, which is an essential element for most missions. I envision this will be provided by a backbone constellation that will include inter-satellite links where performance and reliability of the constellation are extremely high and not dependent on single spacecraft. So think about some spacecraft as being disposable and being replaced on a cadence and incorporating new technologies. Solar energy, nuclear power, and propulsion will likely be key elements in this space infrastructure. In this time frame, we also expect a combined human-robotic presence on the Moon and Mars. Mission areas we have today, such as remote sensing, communications, space sciences, will become even more critical. Similarly, the ability to detect and track space objects will be ever more important and more challenging given the exponential growth in the sheer number of spacecraft. I expect we'll see a blending of some of these mission areas with different purpose payloads hosted in common spacecraft. The proliferation and expansion of spacecraft will drive the creation of new mission areas, such as on-orbit refueling and repair, and regulatory requirements will likely drive the creation of new mission areas, such as space traffic management and space debris remediation. Other new missions include space tourism, hypersonic transport, and space mining. Today, we're seeing the effects of lower launch costs and the start of proliferated systems in space. I expect these trends will continue and evolve into new business models. Technologies for propellant, cryogenic storage, and transfer are being developed and will be enabling of future space infrastructure, as well as nuclear power and propulsion. We're also making significant progress in quantum communication and remote sensing, which are critical to establishing this space infrastructure. Now, let's hear from our panelists about this future, and we're going to start with Aura. So, Aura, what transformative technologies is Lockheed Martin developing today to make Space 2050 a reality?
Thanks, Nelson. So we're currently working on several disruptive technologies that are key to making this vision into a reality. Some of them, which you touched on, including autonomy, trusted AI, cyber, photonics and interferometric imaging, quantum communications, remote sensing, quantum computing, nuclear power and propulsion, on-orbit assembly, repair and manufacturing, and high-energy lasers and power beaming. So that was a long list, and it would take even longer to go through each one. And so I believe the other panelists will try to touch on some of these technologies as well. But I will talk about one of them in depth, imaging interferometer array. So our vision is to develop an imaging computer that would replace conventional optics and eliminate the front end optics, for example, the telescope in remote sensing systems. The concept is to move from an image plane detection where the light hits the primary mirror, then the secondary mirror, then the fold mirror, and is focused on the image for the focal plane, to move away from that to a pupil plane detection using nanoscale photonic integrated circuits, where the light directly enters the optical system where the interferometric imager detects and generates the image on the pupil plane. And so to do this, seen photons are collected and mapped by nanophotonics waveguide array where the image is reconstructed. And so there's several benefits, which include a 10-time reduction in mass and volume and a shift in complexity from assembly, integration, and test to precision rapid manufacturing that in turn translates to significant cost and schedule reductions. And currently, the ground-based imaging interferometric arrays are operational at multiple different sites, and we have completed a proof of concept demonstration using photonic integrated circuits. And so this will be a very transformative technology and will really enable low-cost proliferated imaging systems that could provide persistent coverage of the entire Earth. Thanks.
Hey, all right, that sounds exciting, and probably some of our audience is wondering, your screen background. What is that? What that means, right? You have a spacecraft, you have no solar arrays, you have a little lens up front, and that is actually a representation, right, of one of these interferometric imagers. Yeah, thank you. That was fantastic. Let's switch to Joe here, and Joe, can you tell us what does the future of commerce and logistics looks like in Cislunar space?
Sure, Nelson, thanks. I'll take a look into my crystal ball here and make some predictions. I first want to look back in time and to really set the stage for that future vision. So NASA has been clear and consistent with its plan to explore and develop the moon. And that plan really goes from a strategy all the way through implementation for Artemis. So NASA, Lockheed Martin, and others in industry are executing on that plan. And we all watched the huge success of the Artemis 1 mission last year. So I would assert that the clarity and consistency of that vision is really creating the conditions for an exciting future in cislunar space. And in my view, the future of the moon is commercial. The future is international. And looking at NASA's goals at the moon, it's really a combination of science, of human and robotic exploration, and capability development that can be leveraged forward to Mars. So that drives what I think will be a new thriving commercial economy to help those goals, help achieve those goals. The moon's future also includes this economy that provides services to government-driven science and exploration missions. So let's think about what we'll see in 2050 at the moon. I think we'll see regular commercial delivery services from the Earth to the moon and back for both cargo and people. I think we'll be able to find, extract, and process valuable resources on the moon to create fuel and to sustain life and support human operations. And commercial companies will use those resources to manufacture basic products on the moon and to build and fix things while we're there. So we can start to rely on things we find at the moon instead of having to bring everything back from Earth. I think that's an important distinction. And commercial companies will be able to plan their businesses around the availability of common commercial infrastructure, things like power, communications, navigation, and imagery, so that we can sort of make every mission a little bit easier by relying on that infrastructure. I think that's going to be a common theme that we see going forward. And Crescent Space is of course, building the Parsec network, which will be a major piece of that foundational infrastructure for that future.
Yeah, Joe, thank you. I think you make a very good point as you start laying out this infrastructure and making that available, right, to the broader industry and broader aerospace community. You really propel and enable this acceleration, right, of the exploration, the use of space. That's an excellent point. Thank you for that. Well, let's switch back to technology here. And Kate, tell us about some of these technologies enabler that Lockheed Martin is working on today.
Yeah, absolutely. So we're working on a lot of really exciting things, and I think Joe teed this up well, and Aurora, which is, there's so much that needs to happen to enable this future. There's probably hundreds of capabilities and even more technologies, and so it's really bigger, as you said earlier, Nelson, than one organization or one entity, even one agency. And so we've really had to look at what are the right roles for Lockheed Martin. What should we be working now to enable this future in terms of stepping stones? And so I thought I'd highlight just a few of the big ones that relate to some of this infrastructure that Joe talked about. So it's been mentioned a couple of times, but nuclear power and propulsion, or power and propulsion in general, advancements there are going to be absolutely critical in terms of dramatically improving the types of missions that you can do, the types of science that you can collect. So think high power generation, dramatically improved ISP related to propulsion. So you have more maneuverability, more ability to get to different locations quicker, pulling Mars to the left, right? Making that journey safer, for example. There's all sorts of uses. I think of power and propulsion almost as platforms, right? Where then missions can say, wow, if I had, much higher power because I've got nuclear and I'm not necessarily limited to the power of today, then I can do all these additional things, make these additional observations, maybe manage space debris, all sorts of things. So I think we're the only company who's won a lunar vertical solar array contract, Lockheed Martin is, and a fission service power contract to date, and we're making lots of investments in that area. So I think of it as a power portfolio, both generation and distribution, putting that power where you need it and when you need it. And ultimately, hopefully that will be a service, kind of as Joe outlined, as an opportunity so that many players can come and leverage the power that will be available. So that's one area, a big focus for us. Another, I'll highlight just a couple, but another is habitation, crewed habitation. So as we move further out into space, right, there will be more opportunities for more people to go to space. If you actually look at the numbers, it's not very many, and so we'd like to change that, certainly by 2050. And so more opportunities in lower Earth orbit, which has certain conditions and needs, but it's much easier to get back, right? But then if you talk about longer stays at the moon, you need different life support systems and different crew interfaces and different in-space medical type technologies. And so we're working on all of those things, the right structure, et cetera, and then on to Mars transit and on to Mars. So all of these systems are sort of feed forward, and in fact, in many cases, the same systems you would use sort of plus as you build out. And then two other things, the ability to, when you're on other worlds, right, surface mobility, whether that's the moon or Mars, you need to be able to move around, relocate things, change, modify the surface as needed, and to augment crew and help them have autonomy, be able to do, manage better science because you have machines that have capability like they do here on Earth. So we're working on autonomy and mobility, and think that will be critical as a platform, as infrastructure as well. And then finally, I wanted to highlight, the ability to leverage resources off Earth, generally speaking, depending on where you are and what's available, is going to be critical, right? As we mentioned. So there are a lot of different resources and different ways that you'll have to extract and process and get those things. But we're working on a handful of technologies related to that, because when you're able to not have to ship everything from Earth, your costs come down substantially, the barrier to entry is improved. And again, different organizations, different companies, different commercial platforms can then engage, and they don't have to solve all those hard problems themselves. They can leverage what's there. So that's just a handful of things that are going to be needed that we're working now. And I think when you look out to 2050, it's really a scaling of those technologies, where you have more of those things or augmented for the different locations that will be. Thanks.
Hey, Kate, that's fantastic. You cover a lot of ground there, but I just wanted to make a comment on, it really caught my attention when you started with power, right? And you talked about solar on the moon, but also nuclear fission and so on. And if I understand correctly, in our portfolio, you're also leveraging some technologies we developed for directed energy for power beaming, right? Is that correct?
Yes, that's an area we think is going to be really important. So as one that we're focused, and again, all of these are going to have applicability broadly, right? Commercial, civil, defense applications. So
right.
It's a good highlight.
No, hey, thanks for sharing that with us. That's fantastic. So now we're going to switch to David. And David, you led the our Space 2050 Tiger team here, and what are the challenges with envisioning the future of space, right? It's only 27, 30 years out. So what could possibly be hard about that?
Yeah, well, I mean, you heard some of the themes that were so crisply identified by Aura, Joe, and Kate. And when you hear it that way, about power and mobility and autonomy and communications and the infrastructure necessary, it all makes sense. But given a blank sheet of paper and starting with, where are we going to end up in 2050 and what do we need to do to get there was a challenge, to say the least. And so I think one of the things we dealt with there was, what are the technologies that are being developed today? What is the state of readiness? What is the state of the art? And show that although those things are in their infancy today, like we can say that AI, ML, and cyber and trusted AI and autonomous operations exist today, the real kind of sense making and low latency mission operations that we want to see in the next 20 to 30 years are still evolving, and the ability for those to really form a new capability and a new architecture are evolving. And then for Lockheed Martin, making those all available as a service and integrating them into a system for an infrastructure that others can utilize is a tall order, right? So we looked at all those different themes and we really bounded them by the conditions of, what's happening today and what are the obstacles that we need to overcome, and how do we get to where they're truly enabling and we've got an architecture. And so we were always bouncing back and forth between that's not 2050 enough, or that's never going to happen, that's too 2050. And I think we found a really good middle ground. So we talked about advanced sensors and the ability, as Aura was referring to, for flat sensor arrays on small spacecraft to basically serve as high definition continual sensors with a lot of different type of sensing modalities in them. Or we talked about things that are happening on Earth and how we help Earth with our 2050 capabilities that we're developing. How do we go to better drone delivery? Or what's behind me, how do we improve livability of what are called smart cities? How do we take space power and what Kate was talking about, where on the moon you have a mining operation and you need to transmit that power to another activity that's happening, and how do you receive and make use of those power beams for high efficiency? Well, that's also very applicable to things that we're trying to do on Earth. Advanced propulsion, we talked about asteroid mining, robotic spacecraft, deep space exploration and scientific exploration. You mentioned high energy lasers. So we had a team of 25 people who were subject matter experts in each of these areas, trying to identify where it is that we are today, where we're going, and what's the art of the possible, and identify a roadmap and any obstacles that may be in the way. So we've built out that roadmap. We're making investments through our IRAD and through our partnerships and CRAD to make sure that we are knocking those down, increasing the technology readiness levels, and building those into capabilities and systems. So it's a very exciting thing. It's really exciting to see Lockheed as a company put something like this out there and enable the entire community through AIAA to talk about what are the things we need to tackle to get to 2050 vision.
Hey, David, thank you. It's yeah, I really I would just want to pull the thread on that last point you made, right? Because the future of space and bringing us humanity beyond Earth, right, is really a challenge and a vision for humanity, right, and for the entire space community. So this partnership with AIAA and yeah, we started this vision and so on, but as you pointed out, this is not going to be done by any single organization or any single company, right? This is a community effort, and yeah, really appreciate this partnership with AIAA to broaden this and to invite the entire community, the aerospace community, to tell us what is your vision, how can you augment this, and let's come and build this together as a community. I wanted to ask you just a follow-up question there, because you gave us some very good insight about the Space 20 team and how you went about that and so on. So you came up, and I'm kind of cheating because I know that you and I talked, and I've been there with you for the whole process. But you and the team came up with a fairly large number of technologies, right, and in different areas that are enabling of this future of space. Tell us a little bit about how did you went about the prioritization process and where to focus, right? Because it's very difficult to deal with all of those.
Yeah, no, that's a really good point, Elson. So, we came up with a long list of, it was a brainstorming process of, what are all the things that could happen that we want to see happen, that we hope will happen. And we did a lot of primary and secondary research to identify what was going on in the community. and what had been done prior. We're standing on the shoulders of giants to do that. But to your point, more importantly, put together a matrix that allowed us to prioritize those things. So across 15 different parameters that included, as I mentioned, the technology maturity, what we thought would be most applicable to future 2050 capabilities, the market. So, there was a business and strategy element that played into it. So there was a business model attached to these things, as well as, what we thought was most promising across a wide range of different mission areas. And so we graded things across those 15 metrics and came up with a actually very significant list that we had to cut down, right? Because we couldn't do everything. And so there were these top priority items that scored well across the 15 parameters that we then dove into and came up with, the specific areas that had been mentioned already. A lot of them are cross-pollinating. So, obviously in-space manufacturing and assembly utilizes a lot of the AI and autonomy and robotics and, systems engineering. Of course, materials and additive manufacturing technologies that we put into that prioritization matrix. But when you come out the other end, you can clearly say in our roadmap, here are the obstacles, the bottlenecks, and the opportunities if we do manage to clear those. Hopefully that answers your question.
No, it does. It does. And you also mentioned that, as you prioritize and you identify this technology, you started investing some IRAD and pursuing CRAD. So I know, for example, that we made some progress with the power beaming, right? That in Kate's portfolio. Any other areas that we made progress that you want to mention and share with the audience here?
Yeah, I mean, we have made some real breakthroughs in quantum. So there are some significant things that we're doing in that area that are being tested now, that actually we had listed quantum as something that was much further out. And we found that some of the testing that was being done internally and some of the testing that we were doing today on the ground took us much further in that area. In terms of AI, we have some partnerships with NASA that are looking at how we apply AI to distant, high latency, harsh areas where you want to do science exploration, but you really can't interact with the robotic sensors. And so you really have to have something that is super autonomous that can deal with unknown unknowns. And so we've got some really interesting causal autonomy tools that allow you to do that and allow the AI to be super smart about, if I've run into something that I haven't encountered before, how do I work through that and keep going? So there were a number of areas that I think we underestimated how far along we were, and we found those partnerships and are continuing to build capabilities that lead us through this roadmap. And we're going to continue to evolve and revisit the roadmap to make sure that we can readjust and hopefully bring 2050 closer and set new audacious goals as we go forward.
Thank you for the insight there, Dave. Really appreciate it. And that's actually a good cue there to circle back to Aura. So Aura, share us your thoughts on how will AI and quantum systems that Dave just mentioned, right? And if you will, other technologies will help evolve the future of national security and space exploration.
Yeah, sure. So I'll answer this question using a remote sensing example. So for remote sensing, we envision mesh sparse aperture clusters, which you can see visually behind me, expanding into hundreds and thousands of satellites. These satellites could be in multiple different orbits and consist of heterogeneous constellations. And so this mega constellation-based distributed sensing would give us superhuman awareness, as well as a vast amount of information, which would be beyond the ability of any number of human operators to parse through. And so The goal is to use AI to determine truly optimal and trusted decisions from that raw data, which are usually hidden and unintuitive. And this is, as David mentioned, this is different than today's AI, which does provide decisions, but are not always optimal or trusted. And so in the future, we envision that we will need to rely on AI and augment human decision makers at all levels of command with advanced AI data processing and course of action generation that will support all types of operations. And technologies required include scalable AI frameworks, which would enable layers of AI functions to work together to provide a seamlessly user interface. And investments in these areas are ongoing, but to get to this end state, development needs to continue in distributed AI algorithms, high bandwidth communication and processing, leveraging quantum technologies, and top-level strategy engines for constellation-level autonomous collaboration.
Oh, that's fantastic. And so both of you and David talked about quantum. And are you guys referring to, quantum information science is pretty broad, right? Are you guys referring to quantum computing, quantum remote sensing, quantum communications? Can one of you maybe give us a little bit of a sense of that?
Yeah, I think both of us can talk about it a little bit. I'll just say that, yes, Nelson, there are different flavors of quantum, just as there are different flavors of materials when you talk about nanomaterials. What we've seen is quantum computing investments are being made broadly. And so we understand that, that computing infrastructure utilizing quantum will be there for us into the 2050 timeframe. What we felt was more important was quantum algorithms to make use of those quantum computers, quantum remote sensing, and quantum communications. So those are specific, space applications of quantum that are going to be super enabling for what we want to do. And so, Aura may want to get into this, but we have a team working very specifically on quantum remote sensing and enhancing those capabilities, and also enabling technologies for quantum communications. And I would say that some of the findings were that those things are closer than we think.
No, I don't have anything to add. You answered that well. Thanks, David.
All right. No, thank you.
Thanks.
Thank you both. That was great. So Joe, this, the tone of our conversation here, right, has been very positive and exciting, as it should be, right? Going back to the moon to stay, going to Cislunar, going to Mars, all these new technologies that David and Aura talked about. But this is easier said than done, right? This is very complex. Space is an unforgiving, harsh environment, right? So what are some of the challenges that we'll need to overcome in order to make this future state a reality? What are your thoughts on that?
Yeah, Nelson, good point. I think there are many challenges, and really focusing on the moon, but this can apply really to everywhere in the solar system. Every space mission today has to be completely self-sufficient, has to bring everything you need with you, has to account for every contingency. So even the smallest missions or capabilities end up being very complex and costly. So I don't think we get to the Space 2050 future that we're talking about without laying some basic foundation, infrastructure, in other words, that space missions can rely on, because that idea of infrastructure makes really a different future where missions can rely upon that infrastructure, so they don't have to be as self-sufficient and as all-encompassing. So, if we look at thinking about the moon, in NASA's Moon to Mars architecture, they identify 4 core enabling elements of infrastructure. And it's critical for the moon, but also could apply to Mars and even Venus. I think if you start to think about going beyond to Jupiter and beyond, maybe it's okay that each satellite or each mission capability brings everything with it. But for closer to Earth, we ought to be able to have power generation and storage. We should have, and again, on the lunar surface, I'm speaking, I'll use the moon as context, communications. So communications back to Earth and within and among systems that are in cislunar space. PNT, or position, navigation, and timing, is critical for knowing where you are and knowing what time it is. I mean, in order to do computing in cislunar space, we'll need to have local time references so that we don't have to rely back on Earth. There's also lunar domain awareness, or including imagery of the surface and mapping and environmental monitoring. So that helps robotic missions and human missions, again, to make sense of that PNT data and to plan where they're going to be and how they're going to get there. So again, thinking a little bit ahead about the vision here, that infrastructure I think will be commercially owned and operated in 2050 and maybe even before. Companies will sell capabilities as a service instead of selling assets, and that's critical too. So that it encourages private investment and can lay the foundation for that commercial common infrastructure. And so each of those elements I discussed, power, communications, PNT, and imagery and domain awareness, they all have technical challenges as well as business challenges. I think some of the business challenges is commitment from customers like NASA and other space agencies to buy as a service and not build mission-specific solutions to start making that transition to using infrastructure and committing to it. And many new technologies will be needed. Some of them Kate already mentioned. I think looking at for power, nuclear power is really key for low cost abundant power on the lunar surface, and that same technology can be used for transportation, as Kate mentioned. Reliable low cost transportation from Earth to lunar orbit and to the lunar orbit to the surface is also key, because you can't have infrastructure unless you can get it there in a cost-effective way. We'll also need advancements in communications and computing technology, back to the discussion with David and Aura, including quantum computing. We want to be able to enable local data storage and data processing at the moon and beyond, so that we can make decisions and process data without having to go back and forth to Earth.
If I may, Nelson, just something that Joe said triggered a thought. And I'm just emphasizing what you just said, Joe, but as part of the 2050 analysis and building out the roadmap, we weren't just thinking about technologies and architectures and systems. We did look at business concepts, business models, and business strategies, as well as policy and legislation, regulatory. And there was so much there about, we're shifting into a whole new gear here, where, as you said, it will be about capabilities as a service. The government and private actors will be less interested in buying huge assets and operating them, and much more interested in buying things by the drink as a capability as needed. And so putting that infrastructure up and having it available to a larger number of actors will actually become economically feasible. And I think it's going to make it, just like our experience on Earth, so much easier when you have the access to a cloud drive and all these different things that you can buy as you need from places like Amazon Web Services or Google or you name it. It's going to be a real enabler, and I think we're going to see this explosion of activity when you don't have to bring everything with you that you need. Right? You'll come in and do exactly the specific thing that you're trying to accomplish, and you'll have all that infrastructure of the post office or whatever around you and available and accessible easily. It's really exciting.
Yeah, that's the acceleration, right? That we're talking about. But I got to tell, just hearing Joe go through the challenges and everything we need to put in place, right? It really brought me back the thought that it will take all of us, right? All of us in the aerospace community. And actually beyond, right? Tapping into the other industrial sectors and so on, and see how we can leverage that, to further and accelerate our exploration of space. Yeah, that's a very good point. Hey, Kate, let me circle back with you. You listed a very interesting set of technologies there, right? I think you started with power, you talked about mobility, you talked about communications, and that is enabling of this future and technology we're working on today. So from your perspective, right, how will these technologies and services change the future space industry, right? Both on and off Earth.
Yeah, I think that's a really important question, Nelson. So thanks. We've touched on a lot of it, which is that when we have these technologies, they'll enable new missions that we can hardly imagine today, new scientific discovery, and that's why we go to space, right? To explore, to expand our human capacity and knowledge about how we got here and how our universe works and all those things. So I think in terms of the impact, I think we're going to see when all these things begin to come to fruition, there will be more players that can get involved, right? For all the reasons we talked about, there will be a lower barrier to entry, lower cost of access, a flood of new ideas and people who can actually put those ideas into practice. So I think we'll see hopefully more countries and organizations come together and to blend, and that the industry should accelerate and move quicker as a result of that, which is really exciting. I think we'll see scientific discovery that helps us learn more about ourselves, benefit life here on Earth, as folks have talked about, to help us develop new technologies. I like to point out, I don't know how many folks really know or are aware of this, but NASA tracks their spin-off technologies, for example, since the 70s. I think there are over 2,000 technologies that they've spun off or licensed out into industry that we use in everyday products here on Earth that are benefits of space exploration. So hopefully we see an acceleration of that, right? And that's something that people often ask, if you're not in the industry or related to it, right? Why space? Well, that's one of the great reasons. It's not just inspiration. It's in technologies that are in cochlear implants and cameras in your iPhone and memory foam beds, all sorts of things, right? Those are the big ones that often people know. So I think we'll just hopefully see that each new technology sort of is a platform that others are then built on or accelerated, and that will help transform the industry quicker. We'll probably have more and more questions as we find answers. And then I'd like to think too that from an on-Earth standpoint, as more people get involved, more people go to space, astronauts talk about the overview effect and how that perspective from space has given them more of a sense of oneness, right, of humanity. And I'd like to think that will accelerate as well, and will collaborate more, and maybe will help us in some ways be more effective with day-to-day Earth-based type issues that we face, and just as a collective. So I think from sort of a philosophical angle, there's so much value to investing in as an industry and continuing to push for what we're talking about. It's not just because Mars sounds fun, right? It's for all these other reasons. So that's kind of how I think about it.
Yeah, okay, that makes a lot of sense. And I got to tell you, you talked philosophically. I want to talk more pragmatically here. Just share one benefit that I already seen right over the past few years. This renewed interest in space and renewed activity. One of the outcomes of that we're seeing, or consequences of that, is that there's a renewed interest in space at large, which also include our youth, and more students going into science, technology, engineering, and math, which I think is just fantastic for the entire community. So I like to tell my team that space is cool again, and that's fantastic. So that's another benefit that we're already seeing happen here. So let's see, Dave, pulling this thread on benefits to Earth, right? That Kate started us on. How is Lockheed Martin applying what it learns to improve life on Earth?
Yeah, we were really excited about this section of the 2050 Tiger Team activity because the public at large, the people in our industry, the AIAA members, really like to understand that what we're doing has benefit on Earth today, and it does. So we pulled in work on what we called Help Earth, as well as Smart Cities. There were a number of different things that connected. I'll just mention a few. One, we already talked about the multi-use satellites monitoring Earth's changing climate. So, the more sensitivity we have, the more sensors we have, and the more ability we have to pinpoint emissions and things like that, the more we can do to help keep Earth in a good state. And so the sensor advancements are a big part of that. We also looked at, the image that you see behind me, smart cities. So there's a lot of the AI, machine learning, and decision-making algorithms that have these autonomous capabilities that can be utilized by smart factories. So you can really get to an optimal smart factory that has lower emissions, better yield rates, does things generally more efficiently if you start to incorporate some of the feedback loop of the sensor with the AI ML decision-making algorithms. We got into looking at how you scale agriculture digitally and autonomously. This is a big area that's developing outside of aerospace and outside of Lockheed, for instance. But there are some really interesting tools that can be used to advance agricultural science and, again, increase crop yields, improve accessibility for fresh foods in cities. And we saw some big capabilities there that could make large percentage differences. We looked at power grids and wireless transfers. So some of the stuff that Kate was talking about off-world, certainly disaggregated power grids and the ability to do power beaming, compact nuclear power. All these things are things that we can look at, as well as efficient batteries as we see things move more to electric and away from other sources of energy. And I'd say lastly, we tried to delve into automated supply chains. So how do you make decisions about satisfying supply and demand, having enhanced robotics, autonomous machinery, drone support, all these things integrated into a smart city infrastructure. So again, there's a ton of things that we do. I think most of what we do is applicable. It's just a question of making it cost effective enough and available enough to these other industries to implement them.
No, that's a great perspective, David. Thank you. Appreciate that. Let's see. I think we have time for one more question, and I'm going to pose that to, I think, primarily Joe and Kate, because you two talked about that. But of course, David and Aura, feel free to jump in. So both of you mentioned the role of commercial space companies, right, in this future of space and future space economy and so on. Can you elaborate why do you think that role really is, and why it is important?
Sure, I'll let you start if you want.
Okay, sure. Yeah, so I think this is a great question, Nelson. I think commercial companies are an important part of how NASA envisions the future, and like we said before, buying services instead of assets. So I think that is really driving the trend. And I also think in the early days, as we approach 2050, it's still going to be the lunar economy is going to be driven by government exploration missions and science missions. It's going to be a big part of the economy. But what we'll see is commercial companies serving those missions, and then commercial companies serving those commercial companies that are serving those missions. So we start to layer on commercial services that really help everybody and helps the whole economy grow. So commercial companies buying from each other is a really big, it's an important factor. And then also going back to the previous discussion, I think it's more than just space companies that are going to be participating in this commercial market. Really, to foot stomp that from earlier, it's going to be all sectors of the economy on Earth will eventually have a role and a purpose in space. We'll start with sectors like energy, transportation, and mining. But the moon, we'll also need things like tourism, retail, food production, healthcare, even trash collection. Like it's going to be in the future. We need all that things, and it's not a space waste management company. It'll probably be an Earth one that comes up and learns from our sector here in aerospace on how to deliver their service in space.
Oh, that's fantastic.
Yeah, I think it's a great point, and I think what we're describing, what Joe's describing, is there's going to be this phased approach, right? This is a new market. Effectively, we've been doing space a while, but these are truly new markets. And so as you kind of dip your toe in that first phase, it's obviously very government led, and you can do a certain number of things. You get that infrastructure established, but then as more communities can join in, offer services, lower costs, then more things can be services because there's more demand, right? To sell a service, you have to have demand spread across multiple entities. And so
that's right.
I think what we'll see is we're in that early phase where there's demand for certain things now, like what Joe described and what he's doing there with Parsec and communications. And then in the future, there will be additional things, and then, but they'll be infrastructure related. And then in later phases, right, there will be all the things that we have on Earth, hopefully, when you get more and more people up there. So, the market, I think, is testing those. Is there enough demand now? How can we forecast that? This is new. So we'll test that. Some things will be ready now, some things will be ready later. It's an exciting time, and you know, as with all new markets, right? There are you have to test. You don't always know immediately, and but we'll build it out. And so I think it's really important to recognize sort of where we are on that continuum, and know that there's risk, but there's also so much reward and excitement.
Yeah, no, Kate, both of you made a great point, right? We're seeing a nascent, brand new market, very, very exciting. So thank you. I want to thank the panelists. This was part of our dialogue. We have a few minutes left here, maybe for one or two questions. Aura, can you help us with the questions from the audience?
Sure, maybe we can do a quick rapid fire. Okay, first question, Nelson, I think you can answer this one. Would it be possible to move launch within our lifetime, or is LM set on 2050? Early birds will get the prize.
No, as I said, right, the 2050 was somewhat arbitrary, but it wasn't totally arbitrary, right? We didn't want it far enough, but we didn't want it far enough to become science fiction. We wanted far enough so that we could develop disruptive technologies and capabilities, right? But we're always trying to find ways to accelerate and move that to the left. And I think David gave some good examples here on the quantum remote sensing and comms, or I gave an example on AI of exactly that.
Thanks, Nelson. All right, next question, Kate. Are there any gaps in the industry's current technology capability that Lockheed Martin Space aims to fill through the 2050 initiative? I think of things like habitation systems, Martian agriculture, and terraforming when I think about enabling us to become multiplanetary. But I am not aware of current efforts Lockheed Martin is working on these areas, but would love to hear about them if they do exist.
Yes, great question. And I think the answer is there's so many things, right? There's more gaps than there are established things that we can leverage, right? We've got great history we can build on, but I think it's a lot of the things we talked about, here today and more, right? It's this emergence of an ability to get where you need to get to, what destination you want to be at, safely, effectively, sustainably for long periods of time, and then to have all the resources that you need on Earth. Like the analogy we like to use here is, when you move into a new house, you need power and you need water and communications, and you need the family car and all those things, right? So when I think about the gaps for Mars or really far out, it's those foundational things plus all of the other AI and cyber and autonomy, all those things we've talked about. So I could go on for a long time about that, but I won't.
Thanks, Kate. Joe, how do you see civilian sector market-driven stakeholders utilizing and pushing the development of Cislunar infrastructure?
Yeah, good question. I think there are government requirements and government missions, but I think the competition among commercial firms going to serve that government business will really drive the innovation and technology. So I think that is a sort of a market forces will help drive that.
Thanks. And last question to David in the last 30 seconds. Does Lockheed Martin have a tech roadmap with areas where you welcome small business technology and brainpower?
Yeah, I saw a few questions like that float in. Yes, we do work with small businesses all the time. We have an ecosystem of organizations that we connect to do everything we do. And so the technology roadmaps that are linked to the mission areas that link to 2050 are part of that, and how we assess who we work with. And as we said at the beginning, we're looking at 2050 as not a Lockheed thing. It is a humanity thing and a space industry thing that we're all working to pull in the same direction. So we need those interactions, and we actively seek partnerships.
Thanks, and I'll pass it back to Nelson to close us out.
Thank you. I wanna thank our panelists. This was a fantastic conversation. I want to thank AIAA. I want to thank everybody who attended, and hopefully you enjoyed the content, and come learn more about Space 2050 at Ascend. We will be a major team at the AIAA Ascend conference in the fall, and as I I said on the beginning, and you heard many of the panelists here, this is, this is for the aerospace community. We need your help. Come join us. Come join us to build this future. Thank you all.